I know, but we don't know the V and the I. We only know the V.
No.
Yeah.
Small would mean small I.
No, not necessarily. Anyways, let me see what's so funny here. Oh my goodness. Yeah, okay. Suitable for children. PG-13. Where do you get this stuff from? Reddit or?
WhatsApp.
WhatsApp? Alright. Resistivity.
Okay, one last week. You remember RoboCop, the movie?
Of course I do. It's a classic. Who's this?
From the Snake.
Yeah.
Snake?
Yeah, the Snake.
Oh no, too much. He can't take it.
No, back in
That must mean it's really dirty.
It's really bad. It's so messed up.
Oh, then I don't want to then.
Yeah.
Thank you for sparing me.
You'll have nightmares.
Yeah, okay, we'll leave it
I
then.
was prepared for this.
Now, when you say RoboCop, are you thinking the new one or the original?
No, the original.
Yes, good. Good.
That was the first time I ever stayed awake for the whole night.
Watching RoboCop.
Yes,
It's a classic.
twice.
Do you ever see the director's uncut version?
What does it have? I might go see it right now.
It's interesting because I was looking at clips from the original that the rater said they're too gruesome and they have to tone it back a bit for the... Yeah, so I'm like, but it's already pretty gruesome. What is it like if it's too gruesome? Oh my goodness! So, yeah.
Weak.
If you're into gruesome stuff, maybe you can
He definitely.
RoboCop uncut version. And
Is it on YouTube or is it on the dark web?
I doubt it's. I think it's too gruesome for YouTube.
Yeah, I'm definitely finding that.
Yeah. I think the most gruesome part of that movie is when the acid pours on his face at the end.
Oh yeah, that was nice.
Okay, resistivity. You got that written down? Yep. So, all electrical devices, bulbs, TVs, PCs, phones, etc., offer resistance to the current that is passing through them, like we saw last time. A resistor is an electrical device that offers a known fixed amount of resistance. It's used in experiments and circuits. Normally the work done is heat. A small resistor are really just small heaters. So this is a resistor. You use them in experiments. They have a fixed resistance that you know. For example, this is maybe a 1 ohm resistor. So the resistance, the R is always 1 for this. Now in real life it's not really a constant, but like I said last time, we can treat it like a constant. But what will probably happen is when this heats up, the resistance actually changes. It usually increases. So if you leave this on for a while, maybe the resistance becomes 1.01 or something like that. So resistors are just devices that have a fixed resistance. So what affects the levels of resistance in a resistor? So here's a resistor. What do you think would make the resistance bigger or smaller? What are the effects of the OR? So for example, do you think the length of the resistor has an effect on the resistance?
Yes.
Yeah, and what do you think the effect might be? To increase it or decrease it? We think maybe to increase it. So the answer is yes. What about the radius? Yeah, we think it should have an effect. So what would be the effect of increasing the radius?
Decreasing resistivity.
Well, it has an effect, and later we'll see what it is, but it will be to decrease it. Okay. The type of material? Would that affect it? Yes,
Yeah.
of course. Yeah. So we actually have a formula to calculate how much resistance is in a resistor. It's equal to this constant called resistivity, which is different for each material, multiplied by the length of the resistor divided by the cross-section area, the circle area. L is length, A is area, rho is a constant. It's called the resistivity. And what exactly is the resistivity of a material? It measures how much an ability to stop current flowing through it. So most metals have a low resistivity. The units are ohm meters for resistivity, for measuring how much resistivity there is. So basically resistivity is like resistance. It's a constant for the material used. A bigger resistivity means the material is trying to offer more resistance. Conductors would have small values. Insulators would have large values.
That's a P.
That is not a P. That is a Greek letter.
Rho.
Rho. You know your Greek letters? Alpha, beta, gamma, delta, or HO, rho. Like this. You know this Greek letter?
What's the constant?
It depends what item it
It
is.
depends on the material. I'll give you a table in a moment of materials. I've seen the definition of resistivity required on the exam a few times now. I think I've seen it twice in the last 4 years. It's one to ask in the exam.
We used to say opposes the flow.
Huh?
We used to say opposes the flow, not stops the flow.
Maybe opposes might be more accurate. See, I sometimes get my definitions from Wikipedia, but not just the regular version of Wikipedia, something called Simple English Wikipedia, which is an English level more suitable for non-native speakers. This is why I think the word stop is there instead of oppose. Okay, continue. Not yet. Are we just waiting for Fuang?
Only yaya.
Then we can continue. Continuing?
Yeah.
Right. Definition. What's an insulator? You've done this in chemistry, haven't you? What's an insulator? You have, Fuang.
I'm not going to
Oh, you haven't done it in chemistry yet?
No. The order for chemistry topics is weird. It's very weird.
Yeah, it is very, very weird. I don't know why it's so much better.
Who's your chemistry teacher? She knows what she's doing, don't worry. If she reordered the course, it's for a very good reason. Have faith and trust. I know this is difficult for you. You've been hurt before, but believe.
It's not for life.
Yes. Right, so what's an insulator?
Material that does not conduct electricity.
Yeah. I go for a slightly different definition. I don't really like this one because an insulator, I know you're saying doesn't conduct electricity, but in real life, if you put enough current through it, it will. You might melt it, but you will, you know. So I would just say instead of does not conduct, will offer a significant level of resistance.
So that's why a kite would conduct electricity if it was hit by a thunder.
Anything will conduct electricity if there's enough current in it. The only thing you could really do to prevent it is if there was a vacuum. I don't know. With some exceptions, I can't imagine any material being perfectly able to stop a current.
Even gases?
Even gases can conduct, yeah.
Gases are excellent conductor.
Well, it depends on the gas. Neon obviously is a good conductor. Neon is what is used in the lights, neon lights. So that gas conducts electricity. So no, even a gas will conduct it. So anyways, an insulator not always, but usually has a high level of resistivity, and a conductor. What will we say? Yeah, will not offer a high level of resistance and will often have a low level of resistivity. Please note this. Make some kind of note, written note, not mental note. Say again? About water? Water, conductor or an insulator?
Yeah.
Pure water is insulator.
Yeah, but again, I don't like. I would rather describe.
Distilled water is an insulator.
Is it an insulator or is it just a really bad conductor?
Don't play mind games with me.
No, because I don't know.
It might just heat up and boil, but I don't think it will.
Distilled
It doesn't
water.
have any particles in it.
Insulator or conductor? Let's see what it's. Chemistry every day. Yes, it is an insulator. Now that's if you have completely pure, no impurities.
Yeah, distilled water.
Which is impossible.
No, it is very possible.
No?
Well,
H2O.
I know, but the moment you put it into some kind of container,
You can clean the container with acid.
yeah, but maybe you'll dislodge some of the plastic lying in the inside of the container.
Okay, go on. Don't use plastic. Use glass.
Okay, I'll allow it. Okay, let's have a look at some values of resistivity. So please note, you might need these for some of the questions. So the first material we'll look at is graphite. It has an extremely low resistivity value, which means it is a conductor. In fact, it's a really good conductor. This is a very low value of resistivity. So carbon makes for an excellent conductor. You don't need to know the values for the exam, but you need to write these down because some of the questions will require them. Yes, Ron?
How about diamond?
I'm not sure. It's an insulator, isn't it?
Yeah.
But it's also carbon.
True. So I think that's why I put in brackets graphite, because it's the one that's on your like your pencil. Yeah.
Yeah, it's free moving investments between the layers.
Is that what it is? So the carbon, yeah.
And that's why graphite conducting.
Because the free electron. Oh, I see. Because it's more compressed, is it?
Because of the layers in graphite, that's why graphite
Yeah,
conducts.
and it's each carbon is only connected to 3 carbons. And
The structure is different as well. I know. Yeah, yeah. Okay. Next material is copper, which also is a very good conductor and again has an even lower resistivity. So copper is an excellent conductor, why it's used in so many wires and cables. However, it's not, I don't think it'll continue to be used so much because it's becoming more and more expensive.
What's the lowest resistivity in the material?
There have been some experiments that has produced 0. These are called superconductors.
Oh yeah, superconductor.
Yeah. Now, it's extremely difficult to produce these because they require to be at practically absolute 0. But it has been done. It has 0 resistance, which means the current will travel through the circuit and not lose any energy. But you have to spend a lot of energy to keep the superconductor on because it needs to be super cooled as well. So it's more of a theoretical rather than a practical idea.
Can they use it for light?
For what exactly?
For bulb?
No.
Light bulb? They can't.
No, it's actually quite the opposite. Usually the light bulb has a high level of resistance, and this is the reason it glows, because it's glowing hot actually. Next material is nickel. So for me, it's probably more likely that maybe nickel would be used than copper. Maybe not, I don't know. I'm not sure which is cheaper, copper or nickel. But usually alloys are cheaper. Nickel is oh yeah, so no, I was thinking of nichrome, that's what it was, not nickel. So actually nickel, my mistake, nickel is actually very expensive. They used to make pennies out of nickels until nickel became too expensive, so it's not used.
How is a higher level of resistivity then?
Yeah, but it's still 10 to the minus 8. It's this part that's really key. Next now is nichrome, which is cheaper than nickel and copper. It's alloy of nickel and chromium. So it's much cheaper than using an element like nickel or copper. So I think nichrome is used in like electric heaters, I think. It's a conductor. Now on to insulators. So wood. Look at the huge difference between the values here. Huge difference. It's obviously an insulator. The resistivity is giant.
Question.
Yes.
What is the border between conductor and insulator?
I don't know what exactly would be the accepted sort of threshold. I suppose in my head I'm thinking anything with a negative power is a conductor and a positive power is an insulator. But even if you had a material like wood, if you made the diameter small enough, you could make it a conductor. Because remember, we said the resistance is equal to the length over the area in the fraction. So if you made the area small enough or big enough, you know.
Yeah. Yes.
But it's not practical to have a thread of wood. So there's more of a practicality to it. Rubber. Definitely an insulator and extremely high as well. Not as much as wood, which I think is interesting because I always thought rubber was a better insulator than wood, but actually wood is better, more of an insulator than rubber.
Maybe because the melting point is high.
Maybe something to do with that. You could always make a resistor out of a conductor and vice versa. So you could even use copper to make a resistor. It's just you would have to change the length and the area, but it's not practical. So usually small resistivity is a conductor, large resistivity is an insulator.
So nickel is a better conductor than copper, yeah?
Nickel is, no, they're about the same. I would say nickel is a better conductor than carbon.
Graphite.
Yeah. But I don't know. Nickel is more useful because it won't break like graphite. You know, you can't really make a circuit out of graphite because it's snapped.
You can coat the circuit.
Maybe you could coat it with it, yeah, something like that. You could have some kind of plastic coated carbon perhaps, yeah. Okay, continuing now. let's have a look at an example. So if you can just write this down and then we'll do this one. Write or draw, please.
Yeah.
You know this word, Fuang. You do know this word, Fuang.
No.
Don't panic, I'm not going to hurt you much. What's diameter?
Radius times 6.
Huh?
What's diameter? You know this word.
So the circle is
Yes.
and diameter is
See, I told you you know it. Okay.
1 plus
So area over length, length over area.
Length over area.
Is that millimeter or?
Yeah, millimeter. Yeah. Okay, we can do this one now. Right. The formula is rho L over A. So what is the resistivity of nichrome?
1.1 negative 6.
And the length of this resistor?
0.2.
0.2 meters. And the area is pi r squared. And the radius is the diameter divided by 2. What's the diameter?
0.0005.
Ah, yeah, but I'm going to write in. Tell me how many millimeters it was. It was 5 millimeters. So it's 5 times 10 to the minus 3.
Yeah.
Okay. Let's hit this in.
1.1.
Oh, come on. Ah! Son of a gun. No. I want to do it. No. No.
Oh, wait, you want to get, where did you go?
Did you get this? 0.011. No Superman tunes in glass. No, that's Fox, isn't it? What's that now?
I know,
Is it Fox?
No.
The sound is coming before.
Yeah, but which one? Fox, yeah. How many milliohms is this?
Isn't it on meter?
No, the resistivity is ohm meters, but the resistance is just ohms. How many milliohms is this?
11.2.
11.2 milliohms. Yeah. Okay. Yeah.
It wouldn't make a difference if we take the 1.1 times 10.6 and like first divide the L and A and then multiply it by the rho.
Oh, you mean if you did this divided by A?
No, if we did
L divided by A multiplied then by rho? No? Okay, did you write this down? Yes? Okay, so here are the questions for this lesson. As you can see, not difficult, just one formula for this lesson today, and they're all kind of the same idea. So you can start these now.
Are we starting a new lesson or no?
No, we have one lesson today.
What is the next lesson? Because if it's
I'm pretty sure you can finish it, Mr. Steve.
Just 5 minutes. Oh,
no, it's not.
We have like almost half an hour.
No, we don't.
no, it's just 15 minutes.
The time right now is 2:35. Yeah, 15 minutes.
You got this. I believe in you.
No, I know I got this. If you do these now,
Yes. Just a bulb, a switch, and a sub. That's all.
leave me alone. I'm tired. Why don't you try and get these done now so you have no homework in physics?
That's
And then it gives you more time to work on your maths project,
But we also need to practice.
your maths coursework.
Oh,
We can't neglect physics at the weekend. Or we'll leave the homework.
Oh, leave me. I told you this morning when it's due. Don't you remember? Wednesday plus a week.
Okay.
Information like this is important to write down. How about you start these now, okay? And if you get them all done, then we'll either do the answers together or...
Go back home. Because there won't be enough time. Don't play mind games with me.
Okay.
I told you before.
Can we at least pretend? So,
Okay.
if you get these finished and if there's time left, we can have a look at the next lesson. If not, then we'll just leave it then. Or if you want, if you get these finished and none of them were a problem except for maybe one, then I can just do that one. Do you know? Like last time. Because I don't think you'll have any trouble with these. It's just one formula. You can handle it.
Of course.
Yeah. Alright, so get started now.